Hello everybody, good afternoon. I'd like to briefly complete the lesson that I've started during daytime. So briefly, I'd like to talk about how the energy flow in the ecosystem. If you see this in the ecosystem, we started with the lessons with asking questions. What is the source of energy that sustains the ecosystem? Is the energy that comes into the ecosystems to get lost? So these are the two questions that I asked you in the beginning. Now if you look at there is a question here in these pictures, the energy at the base, the primary producers or the producers, just the producers gain energy from the sun and produce around 10,000 kilocalories. As it moves over the trophic levels, different trophic level like primary, secondary and tertiary consumers, you're going to see that energy is being lost to 1110. Ultimate consumers receive just a very less amount of energy. Therefore the food chains and food waves are very short. Now, just to recall back what is ecosystem, we said ecosystem is a biotic and abiotic components, and also we see a lot of biotic and abiotic factors that involves within the ecosystem. Now, talking about the energy flow, you know that energy comes from the sun, and it is the energy is being converted into chemical energy, and this chemical energy is being stored in the primary producers. These are some of the primary producers. All the green living organisms are the primary producers, and these energy received from the suns move from primary producers to the secondary consumers, or the primary consumers, or the secondary consumers, and also to the tertiary consumers. All right, we also know about the law of thermodynamic, where the energy can be neither created nor be lost nor be destroyed, and however it can be converted into from one form to another. Similarly, the second law of thermodynamic also states that the energy the loss of energy with the conversions usually in the form of heat. So we also know that if the energy has to get lost or dissipate, this has to happen in a form of heat energy. The heat energy still exists but cannot be used if it is lost. Right, it is very similar to the car combustions, where 50% of the energy is being almost lost. Here now, if again once more the question comes, how the energy moved from one trophic level to another trophic level. Like algae is a producers, and hagfish is a primary consumers, and the largemouth bass is secondary consumers, and this eagle is a tertiary consumers. Alligator is the ultimate quaternary consumer. How does energy flow in an ecosystem? The energy flow in an ecosystems in a one stream from producers to the various consumers. All right, these there are, when you say all the herbivores, all the plant eaters are the primary consumers, and carnivores are those which consumes the herbivores or any others. All right, then let's talk. So when you say carnivores, we talk about the secondary consumers, tertiary consumers, and quaternary consumers. uh, these animals, when it dies, it goes back to the soils, and these organisms has to get back to the soil, and it is acted upon by the detrivorous living organisms, and this decomposes or decays the living matters, or even it can be the scavenges by the eagles, vultures, and ultimately eagle vulture dies, and then it is acted upon by the decomposer. So it's very important that every living organism that gets energy out of quaternary or tertiary or secondary living organisms would get back to the soils and is being acted upon by the decomposer. So decomposer get energy from the all those secondary, tertiary, and quaternary consumers. So, all right, this I have already said. The energy received from the all the consumers, and ultimately it will make into chemical. Those animals, dead animals, which made into chemicals. This is how the cycle happens. I mean, to all those prime producers, primary consumers, secondary consumers, tertiary consumers, and quaternary consumers, and these are producers are all the green plants. Ways of obtaining energy is yes, these are the different ways of that producer gets energy from the suns, and they are autotropics, and yeah, most energy during the this energy received from the sun is being converted during the photosynthesis process, and consumers obtains its food energy from the another living organisms. If you look at these how the producer get their energies, it's very interestingly being explained here. You're going to see that during photosynthesis the sunlight is being used, and during chemosynthesis chemical is being used. So just look at these, the two ways how these the different energy, sorry, the sugar is being formed in the different environment where there is no sunlight, but still it uses some chemical to produce sugar, whereas there is no light, green plants, cyanobacteria, these will produce sugar directly during photosynthesis. And non-living source for this here, what we are saying is commonly both the plants and green plants as well as the non-green plant that lives deep inside the sea uses non-living substance for the source of energy. Now here I would just like to explain you how energy flows from primary to the secondary. However, what is important here is there is a two dotted line. One with the pink dotted line indicates the energy flow, and the another one is the dotted pink dotted line shows how the energy is being lost during each stage of the trophic level. So first trophic level there is a loss of energy, second trophic level there is loss of energy, tertiary secondary level there is loss of energy, and ultimately even the Dreticurus loses its energy while it is trying to decaying this matters, dead matters. So this is just to indicate there is a loss of energy in the form of heat. Uh, just look at that how sun's energy can be stored in a glucose and is being converted to glucose, is being converted into ATPs and is being utilized by the different trophic level animals. Here the it is just wanting to show how the light is being converted to a chemical energy. These kind of conversions, the chemical energy is being stored and it is called biomass. Biomass is the total dry mass of organisms within an area or a volume. So total mass that is being formed by the chemical, by the photosynthesis is called the biomass. So this is very important to understand what is biomass. It's a total energy stored in living organisms. So in the most of the ecosystem gets their energy from the sun through the consumers, and it gets indirectly by feeding. Right, this is just to show that there is the energy moves from the different trophic levels, and the question is why are more organisms in a why aren't more organisms in a food chain, or why food chains are quite short. Probably here you need to think about what is the answer. Uh, the energy released from the carbon by the respirations is used by the living organisms. However, it is being converted into heat energy. So the energy that is being stored in a carbons is being utilized by all the secondary organisms in a form of an ATP, and these ATP is being ultimately dissipated or lost in a form of heat. Now the question is, where does this heat go? Alright, the living organisms cannot be converted. Living organism cannot convert the heat to other forms. Therefore, organism can convert many types of energy, like chemical light energy to chemical energy to kinetic energy, chemical energy to electrical or the electrical energy in the neurons, chemical energy to the heat energy. However, but once the energy becomes heat, organism cannot convert into other form. That's very important. So heat loss in an ecosystem. Heat is generated by the mitochondria during respirations, and all those these helps both ectothermic or ectothermic or endothermic animals in both the ways, because even the cold-blooded animal need to keep his body warm. These heat lost is no way it can be gained back. So the heat moves from the warmer area to the colder. So heat loss is lost to the environment, and heat in the ecosystem is eventually lost into the space. Alright, now the energy loss between trophic level restricts the length of a food chain. The answer comes here, why that food chain is very short. Uh, Food chain or even the pyramids, if you look at these trophic levels are quite short. It's because the energy is lost between the tropics, and that restricts the food chains and the biomass of higher trophic levels. Alright, here if you see, the baseline begins with a higher energy, and as it moves upward the energy becomes lesser and lesser. Like here, for example, if you look at the producer has got a large amount of energy, primary consumer has got a very less amount of energy. Here 100 joules started with 1000 joules, then becomes 100 joule, 10 joule and 1 joule. Tertiary consumer gets 10 joules, so which means they get very less energy, therefore the chain becomes very short. Likewise here it is in calculations of if the producers has got this much of energy, what is the energy obtained by the ultimate consumer. And this is also the reasons why there is less tiger and less crocodiles, less eagles and vultures. Alright, now I'm going to come on the primary productions, fixing the energy by the autotrophs in an ecosystem. The rate of primary productions, amount of energy fixed over a period of time, is called a primary gross productions, or GPP, the total amount of energy fixed by the autotrophs. And also the net amount of productions is net amount energy is left over after autotrophs have met with their metabolic reaction, because every energy is being trapped, is not all used is being stored for the primary consumer. However, it also utilizes some energy. So the gross primary production is being is slightly higher than net primary productions. Net primary production is a minus of what it has used for its own survival. So primary gross productions is rate at which ecosystem produce, capture the stored chemical energy as a biomass for a length of time. Net production is the rate at which the plant in the ecosystem produce net useful chemical energy, equal to the differences between the net production is GDP minus respiration. Respiration is the energy used by the plant during respiration. So this is a way to show towards how the sun provides energy and how it moves. Here there are two different colors. One is blue, and another is purple. Once more, the purple one is to show the respiration in each state of the tropic level. The final one is, if you look at 20,810, energy was uh, converted by the primary producers into the biomass. However, finally it got dissipated into heat during respirations and gives to 20,810, which means what is being consumed is being produced here. So all the energy used is being thrown back into the space. All right. Now this is just talking about the secondary biomass, new biomass, that is rate at which the consumer converts the organic materials into new biomass. So all the consumers eat from the prime producers, and that is called the secondary biomass. So now this is not so important. All right. Now we will see the largest depositions is in the largest production is in the marine, by the marine planktons, where it try to produce it produce by using a lot of minerals that is available in the oceans. So the coral reefs and is the largest ecosystem that is being formed by the algals or the phytoplanktons, using mineral available in the oceans. The terrestrial productions is generally increases with the moisture. This experiment has been carried out and found out that how the productivity or the biomass increases with increase in the certain factors. They found in their studies that increasing moistures and the temperature increases the production, primary productions. So that is very important. Another thing is the primary production is also increases with increase in the mineral nutrients. Like if NPK, any of the minerals are being increased, the productions of the primary productivity of the consumers is being increased. Now these are the very new terms that we have already used. With this, I would like to say thank you very much. I hope you understood. If there are questions, we'll discuss later, but you need to raise this in your in the class. Thank you very much.